Hello, AP Stats students. So today we are reviewing chapter 13.3, and this is just a total recap of the observational studies and experiments, but then we're also going to talk about confounding variables today. So first we're going to talk about block design, and when groups of experimental units are similar, it's often a good idea to gather them together in blocks. So by blocking, we isolate the variability attribute to the differences between the blocks so that we can see the differences caused by the treatments more clearly. So in this example, in the picture down below, you can see that they're blocked by males and females, and it just really, you see the differences caused by the treatments more clearly. So it's a really good tool to use. So on to statistically significant. How large do the differences need to be to say that there is a difference in the treatments? So that's where statistically significant comes in. I can never say that right. But basically it's just when an observed difference is too large for us to believe that is likely to have occurred naturally, we consider the difference to be statistically significant. So what we usually use is we use a p-value of greater than 0.05 to be considered statistically significant. But so in other words, if you can't calculate the p-value for some reason, what we do is, let's say if I flip a coin 100 times, we expect that to land on heads 50 times and tails 50 times. But let's say that I flipped a coin 100 times and got 94 heads and only 6 tails, then the 94 heads would be statistically significant from what we expected it to be. So it's just when the observed data is statistically significant from what the expected data would be, then we would report those results as it is statistically significant to consider the results because it was different from what we expected. So next we're going to talk about confounding variables, and when the levels of one factor are associated with the levels of another factor in such a way that their effects cannot be separated, we say that these two factors are confounding. So basically they're anything in the experiment and it's a variable that could impact the experiment in a different way, but we aren't measuring it. So a confounding variable then is associated in a non-causal way with a factor and affects the response. So because of the confounding, we find that we can't tell whether any effect we see was caused by our factor or by the confounding factor. So down below, it does a really good job because we're testing to see if the activity level impacts weight gain, but a confounding variable would be how old they are, because even though we're not testing that, it could impact the experimental results in some way. Okay, so on the AP exam, they just combine lurking and confounding variables, but for the video's purpose, I'm going to go ahead and explain what a lurking variable is, but it's very similar to a confounding variable. So a lurking variable creates an association between two other variables that tempts us to think that one may cause the other. And this can happen in a regression analysis or in an observational study. A lurking variable is usually thought of as a prior cause of both y and x that makes it appear that x may be causing y, but in reality it is not. So confounding can arise in experiments when some other variables associated with a factor has an effect on the response variable. So since the experimenter assigns treatments to the subjects rather than just observing them, a confounding variable can't be thought of as causing that assignment. And a confounding variable then is associated in a non-causal way. So basically what they do is they just clump confounding and lurking variables. So for the AP exam, just remember that they're basically the same thing, and they are variables not tested in our experiment, but could impact the experiment in some way. Okay, so this is just talking about what can go wrong. So when we can't run an experiment, it is a good idea to do an observational study instead. And another thing is just to be aware of confounding variables. Make sure you use randomization whenever possible to ensure that factors not in your experiment are not confounded with your treatments. And when confounding cannot be avoided, report it with your results. So just make a note like that there are confounding variables and what those confounding variables are. So yeah, thank you for watching. That was chapter 13.3, and I hope you had fun in this review, and I hope you get a 5 on your exam.